today we will divide the class in three different moments, okay? The first one is to introduce the topic. The second one, we are going to work in groups. And the third one is to present our results, okay? So the topic for today is distance, okay, between, thank you, Eric. The distance between 2 points, okay? All of you were working on that on IXL. Do you remember the formula to get the distance between the 2 points? Yes, tell me. C squared A squared plus B squared. Okay, is this the formula to find the distance? No. What is this? Please, tell me what is this? Okay, what is this formula mean? No. What is that formula mean? Why you use that formula? When you use that formula? Okay, or say it again. To find the hypotenuse in a right triangle. Okay. So just make a small review from from the last week. When we have a right triangle, we have two legs. Okay. Could be A, could be B. Mister, can we switch the name? Yes, you can switch it. Okay. Could be A, could be B, okay? But this one is the one that we cannot switch because that's the hypotenuse, okay? So to find the length of the hypotenuse, we use this C squared, it's equal to A squared plus B squared, okay? So with this formula, we find the square of the hypotenuse. Then, after that, we need to find the square root, and then we have the length of the hypotenuse, okay? But, I don't know if some of you already start with the IXLs about distance between 2 points. One of you start doing that? You, okay. No, you. Oh, Sarah, really? Tell me. There was one Excel that I posted the last week that was about finding the distance between 2 points in a coordinate plane. And they give you a formula. Do you remember that formula? Yeah, sure. In a plane, we have 1 and 2 points in a plane. Here the question is find the distance between the 2 points. Okay, if we go back, okay, in previous knowledge, we know how to find the slope. Okay, and even if we trace here, we can make a right triangle. Okay, but there is a formula to find the distance between 2 points, and the formula is the next one. Distance, it's equal the square root, okay, of x2 minus x1 squared plus y. This is 2, this is 1, This is y2 minus y1 everything square. Okay? That's the formula to find the distance between 2 points. The distance. So, this point, exactly, this point, tell me the order pair for this point. Uh-huh. 1, 2, 3, 4, 5, 6, 7. Everything negative. Okay, perfect. -7. And Grace? 1, 2, 3, 4, 5, 6, 7, 8. 8 positive. And for this, 2 and 4. Okay? So, x2. Let's find the distance. X2 is 2. Okay? And then we are going to subtract -7. Okay? We are not going to remove this negative. This is part of the formula. And the negative that is next to the 7 is because it's negative. Okay? Plus. Okay? Y2 is 4 minus yes. Here. Okay? So here we have 2. This becomes positive. Okay? Negative and negative becomes positive. So here we have 2 plus 7. Okay? Square. Plus. Here we have 4 minus 8. -4. Square. Okay? 2 plus 7 is 9. So 9 squared plus -4 squared. 9 squared, 81. Plus plus 16. What is 81 plus 16? 97. So the distance between the 2 points is the square root of 97. 97 is a perfect square? No. Okay, so that could be 2 points between what and what? 8 and 9. 8 and 8 is 8 times 8? 64. 9 times 9? Okay, so no. 10 and 9. Why? If we estimate the square root of 97, it's going to be between 9 and 10 because everything that Grace explained. Excellent. Okay. Okay, so that's how you find the distance between 2 points. All right? So, for that, let's do this. Oh no, it's better. The question is, imagine that we are in our gym, okay? We have a different colors, okay? But that's not the point. The point is here. Belle, help me with the question, please. How can Okay? I love your face. let's do let's do this. Let me explain everything, okay? We're going to move, well, one of each group, okay? Not everybody. Or maybe two. Two of each group. Okay? With Bell Hill, Friday, we put some tape on a different positions. Okay? One tape is in the middle of the, not exactly in the middle of the basketball court, but it's between the two sides of the basketball court. Okay? Just to have one point in common for everybody. Okay? And then we mark two different seats. You can have your own seats, yes. We only mark two seats, okay? For why? Because if we use the 3 points, and when I say 3 points is here, we have the distance from the point on the basketball court to the place, okay, to the seat, and we also have the height, okay? With this, you already have a right triangle. You have two different points where you can find the distance. How? Imagine that this point is in 0 and 0 in the origin. Okay? This point that is in the middle of the basketball court, that could be our origin. Okay? 0 and 0. And then we have a distance, okay? A linear distance. And then we have some height. So, the idea in this problem is you, okay, as a group, first finding the distance, okay? Share us where are the best sitting spots in our gym, okay? Bell and I will already help you with some measures. If you need some measure difference, you can do it. Okay? Maybe you're right, eh? But let's do it using math. And let's see if you are sure with that. Okay? So what I'm trying to do with this is to connect everything, okay, the Pythagorean theorem, the distance formula, with something real. Okay, something that you can really use it. After after you find all this distance, the idea is that you talk each other, make a reflection about that, okay, share all your different points of view and decide where is the best seat in our gym. Okay, for that, you're going to create a small, not too big, presentation about what you find, what are your reflections, okay, and what about your research and your math are or is the best seat on the gym, okay? For the last 10 minutes of the class, each group is going to present the results, okay? And the groups are the next one. In group 1 is Grace, Bell, Seiya, and Viola. In group 2 is Victor, Mateo, Andrea, and Joyce. Eh? I really? Oh, yeah. Victor, Mateo, Andrea, and Joyce is the group number two. And group number three is Ethan, Tiawan, and Lucas. Okay? So please, two of each group, come with me to the gym to show you where we have the 3 points. Okay? And how you can. Yes, tell me. Yes. Okay. Hey, good question. Are we going to use the distance formula to find the distance? Yes, of course. Okay, that's the idea. You want to say hi, hi. Okay, let's go. Two of each group. No. Okay, for Ethan and Tiawan. Okay, yes, you can go. Yeah, Mateo, who's the other group? Andrea. Okay, hey, correct. I'll let you ask. Yes, you're going to find the distance. Okay, after you find the distance, you're going to tell us where, according to your distance, is going to be the best position to watch that. Mine. Okay, look. Grace, come. Yeah. Here's the point number one. Okay, everybody's going to use this point. Okay, from this point to here. From here is a linear distance. Okay. So, okay. So from that point to this point is 8 meters and 7 centimeters. Okay, linear. Okay. And from here to a person sitting here to the eye vision line is 95 centimeters. So this is the height. Okay. This is one leg. This is another leg. And from here, from 95 to that point is your hypotenuse. Okay. Here's the second one. From that point to here is 10 meters, 1,000 centimeters. And then from here to a vision is 2 meters. Okay, so here you form a right triangle, and from here to the point number one. The best of you. Do you want to find that maybe closer for you is the best? Maybe. That's why you're going to find the distance. And after that, you're going to decide according to another factor. Could be yes. No, the first distance is from this point to the point that we have in the middle of the basketball court. Okay, and then from this point to the middle of the. And then you can compare. All right. You got it? Easy point. Imagine that we have here. This point is 2 meters. This is a straight line. That from here to the middle of the basketball court is another leg, and from this point to the point exactly is the hypotenuse. This hypotenuse is from 95 height to that point. That's what I want that you find. Find the distance. I'm not asking for the hypotenuse. Okay, between this point to that point and this point to that point. If you want to find also this point, do it. Okay. So this one is x squared or the x1. Look, to find the distance from here to there is x2. X2. This is x2. This is x2 minus x1 squared plus y squared. This y2 minus y1. Come. Make this a coordinate plane. This is a zero. This is a zero. Okay. Zero zero. Okay. Come. In this x is 1,000. Here is 1,000 and 0. And here is 1,200. Because this is y. This point is 1,000, comma 0. This is the other pair of this point. And this point is 1,200. Yeah. 1,000x 200y. In a quarter plane. Okay. That point is 0 and 0. Okay. This point, this is 1,000 and 0. Because you are exactly on the floor. You don't have any y. Okay. And this point is in 1,200. 1,200. And here you have your right triangle. 0, 0. That's that point. This point is 1,000, 0. Exactly to find the distance. Right. You got Okay, who's going to present? You? All right, perfect. Ethan, come and help Tier 1, please. Help him with the paper. I'm gonna help him with the Google Slides. Okay, yes. Uh-huh. Mm-hmm. Okay. 40,000. Mm-hmm. Mm-hmm. Okay, so the distance. Mhm. 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 Perfect. Thank you. Good job.